Hello, everyone. Just give me a moment. I'm going to share and we should be ready to go. Just one moment. Okay, I think my slides should be visible. So let's start. So I'm actually like giving the presentation on behalf of my colleague because unfortunately he couldn't give the presentation due to some personal commitments. So let's get started. Basically, this work is kind of like our contribution towards an investigation towards consumer computing ecosystems, but more from the security-driven integrational part. So I guess you could say the virtualization of reassimilation in some sense. So let's dive into it. So one of the main introductories, or you could say the main terminology behind this particular investigation, or where this basically stems from, let me give you some context. So, the main contribution towards this work is basically like moving towards the fact about how modern computing devices are becoming, more robust, more powerful in terms of security-driven perspective integrations, but in terms of cost, repairability, restructuring, and reutilization, how much are I guess you could say, architectural improvements in terms of security, hardware integration, cloud services, as with data increasement with most of our fields. So the main question comes that from a security-driven integration, does it really reduce the repair autonomy and data recoverability in a lot of sense? So there's a lot of ownership issues, a lot of post-failure recovery, and there is a huge remark in terms of how the repairing is performed. So let's dive a little bit more. So we will mainly be looking at the Apple ecosystem. Now, I know that a lot of you might be like, why particularly Apple? Well, I think it's better that you go through the presentation first, then it will make more sense or why this was kind of approached in this particular way. So one of the main research question that we were asking ourselves, like in terms of an ecosystem with a 1 billion-dollar company where they have so much access in terms of whether it's services, whether it's encryption, whether it's data, whether it's operation of computing devices, integrated peripherals, hardware, software. So Apple is like one of the biggest platform shareholders in terms of both from an ecosystem standpoint and also device perspective, strategical market value in a lot of sense because yes, they're a very huge tech company and they have a lot of good contributions. Like if you look at some of the MacBooks or I mean most of the iOS devices, they have a built-in architecture which is like both from a system level standpoint and a framework architectural standpoint, but in terms of modulation and like in terms of integration for unification with other device peripherals, especially when it comes to like repairability, there is still a lot more inside in terms of recoverability and repairability. So higher integration may be a very good unified bound in order to create a very big seamless ecosystem, which what Steve Jobs had initially envisioned. But like as every single mechanics, there's always pros and cons. So let's dive more into like our approach in terms of like how we try to understand both from the hardware level to the micro level to the OS level, and also taking into consideration about the security and how this modular integration in terms of performance also holds up. So we kind of like took the framework in terms of different system variables, which is performance density, security hardening, ecosystem integration, modular repairability, post-failure recoverability, and integration intensity. So, in terms of performance, of course, Apple iOS devices hold up a lot better than most of the stable or like high-end performing machinery that is currently available in the market, which explains why they have so much dominance in the marketplace as well. But at the same time, from a company standpoint of view, you also have to take into consideration that when a major company with that much, I guess you could say, control over its own system, there are a lot of things that they can, you know, have ownership over because this is a sustainable ecosystem, right? From a device engineering perspective. But at the same time, this is also a product. So thinking about a product, the usability after post traumatic stress, you might say, or damage, or any kind of issue, what does that look like? And from the security-driven structure, is post-failure recovery probably not the right terminology in terms of computing and also in terms of product management? So from a standpoint of a trade-off model, as I mentioned, there's a reason why iPads, Apple Watches, AirPods, iPhones, MacBooks have so much global market share, whether it is in US, in UK, in Europe, in Asia. They have dominated the field if you look at the type of devices that they have been producing. And this is kind of like from last 2 years. So this number and graph basically speaks for itself. So like I've already mentioned, the performance is very high. The system integration is also very powerful. But if you look in terms of repairability, usage, and post-recovery, there is still a lot more work left to be done. And especially like from a high integrational standpoint, there is still a lot more coverage that is being missed out on. Now, in terms of like how Apple thinks from a supply chain point of view, I know that as a large big tech company, you have a lot of integration in terms of your design, how the device basically going to look, and in terms of the ecosystem, what type of relationships will it have with its, whether it is the microcontrollers, the SoC, or the integrated device chipset that is going to be used in terms of bottleneck or performance, both from a hardware standpoint of view, from a software standpoint of view, then the suppliers, the, I guess you could say, integratable devices or the components, the sensorial inputs, and then putting that into manufacturing with the industrialization in terms of quality control for every single iteration or mass produced device production, then going into retail and then basically utilizing them from the overall management point of view. So it works and it goes both ways, basically. But if you consider from like failure or like components standpoint of view, now I'll have to dive a little bit deeper into modular design in terms of system architecture, both from the structured failure and from storage or like logical, like NAND or MOSFET issues. Recovery conditions in terms of authorization repair and independent repair. I think most of you are familiar with this, that Apple, even though they have some of the best performance in terms of CPU and GPU, like if you look at some of the big tech companies that are producing some of the best high-end laptops or desktop PC components, Apple is still holding like one of the best major milestone, whether it is a single core, whether it is a multi-core, or whether it is innovatingly designed. And you also have to take into consideration of the beautiness or the beautification of the product itself, because Apple produces some of the most high-end performance devices with an engineering outlook. So you have to take that into consideration. But along with that consideration, you also have to take into account the redistribution of resilience, as I was mentioning, that what happens when the device faces any componental or sensorial issue, if there is any cause of failure, because in line of electronics, of course, in terms of daily usage, there will always be problems. As humans, we're to error, so we will always have that. But in terms of the integration, if I think about the cloud synchronization, which is one of Apple's very lucrative design, but in terms of ecosystem restoration, like for instance, I have done multiple case studies and we've tried to check and cross-check with most of state of the art for most people that have used these types of devices. And one thing stood out very much is that most people usually complain that after your device gets into any kind of issues, they usually necessarily need to have it replaced rather than, updating or probably changing some of the materials. So this is where that management production pipeline also comes into play because if you look at Apple repair shops, you have to go into authorized Apple shops where they have specific components, specific hardware, and specific engineers that basically does this process. And sometimes if the storage is not still intact, data becomes completely unrecoverable. So resilience has shifted from hardware modularity to cloud mediated continuity, but at the same time, it also leaves a huge block of broad failure in terms of when you have inaccessibility to your own data and you're using this performance from a secure and encryption device. So it has both contextual awareness, but also at the same time, some of the issues you cannot ignore. Because yes, you have high performance engine, high performance technology. You have the leading industrialized cores with high-end processing powers. You have some of the latest technological advancements in your device, which is producing faster computation, both from the central processing point of view and from the graphical point processing of view. And you're using some of the latest technological advancements from your chipset to your microcontrollers to your gates and so on. But if you look at the market share and the amount of device production in terms of post recovery, the number kind of like shifts a little bit degradingly. Now, why is that? So, one of the reasons is because, as I've mentioned, people's perception when it comes to post recovery is always a little bit neglected in a lot of sense because, for instance, because it is an entire ecosystem, you don't have any other compoundability to take action for it. So you cannot switch your variables whenever you want. This is what I was talking about in terms of market share value and central independence, because Apple still has a lot of its competitors outmarked because they are within a confined ecosystem of themselves. This produces a whole lot of questions in terms of security as well. And if you look at from the security or recoverability option, this integration kind of hardens deliberate design priorities because now I will say some things maybe might provoke some iOS users, but you have to take into consideration every single year when a new product or a new deployment is given, you are increasing price, but the performance, security, or stability, or repairability, or recoverability is still not there. Post-failure resilience is increasingly dependent on the ecosystem. And so if you have a problem with your device, you basically have to get a new one. So at the same time, for your cost and the amount you are spending, you are getting the performance. The security is there, but the ecosystem is also damaging your financial stability over time. Because if every single year you have to purchase a new device from an integrated standpoint of view, that is very costly. And this is one of the major reasons why a lot of people cannot afford or go down the line of iOS because once you get inducted into the system, you have to connect everything. So basically, you need to integrate all the other device peripherals. But from a psychological and also from a financial standpoint of view, this can be very hard for a lot of users. So this is why Apple always says that, you know, our product is not for everyone. But you also have to take into consideration that if you take some maybe actionable insights, both from your engineering perspective, from your hardware to your software, you can most probably have a little bit more consistent patterning. This is something that we kind of try to like include because if you have an encrypted system, but if that system is recoverable, both from forensic access, yes, of course, I know you might say that what happens when somebody else tries to, you know, walk the other path and tries to create a paradoxical issue. Yes, of course, but you have an ecosystem that has its own framework. So whether it is from the microprocessor side, from the microkernel side, or whether it is from a boot standpoint of view, you can create this particular system and give access based on the post production, whether it is on dependence or whether it is on services. Because, for instance, if you look at it, from a singular point of view, let's say I purchase a Mac device. I used it for 1 year. It gave me some of the best performance, all the great things that I require. It performed at its peak. But at the same time, unfortunately, because of a simple accident, somebody spilled water over it. Now my device completely is booted off. I don't have access to any of my cloud storage, or I forgot that I didn't put everything on the cloud. So basically, I lose that 1 year of work in within a second. So I understand that the point in terms of being mutually exclusive to give authorized openness and close integrated system like what Steve Jobs initially visioned, like a verified closed loop system. But I think that if you have cryptographic handover, where you have certain protocols for hardware, software, and key replacements under verified ownership from your own products and your placements, I think you can have a much more better life cycle in terms of both from all your computing peripherals in terms of whether it is electronical waste and also from your devices that can be recovered in a much more sensorial environment because you know on a particular system design, a machine or a sensor can have degradation, but at the same time, you can have particular facilitation for particular system functionalities, which can help you elevate or reuse that particular system. This is something Android has been able to do for quite a lot of time, where Linux beats Windows in a lot of operational management. I'm not putting any kind of, you know, barrier in terms of iOS, but from a system standpoint, this seems like more of a market value picking instead of like focusing more on improving the actual autonomy of the entire system architecture. Now, I know that a lot of people might have different opinions in terms of having the resilienceness because yes, when you have a multi-corporation that controls some of all these iterations from one standpoint of view, it can go one-sided as well. So you have to take that into consideration because this is its own unique trait. So, like I mentioned, pros and cons. But this is kind of where we live the audience, decide to have your opinion. And if you have any questions, feel free to reach out. Or if you have any guidance, feedback, or suggestions, feel free to reach out to us. And that concludes my presentation. Thank you very much for your time. And I conclude my presentation here. Thank you very much.